So in this video we're going to talk about how to find a sine and cosine function to fit a specific set of data that we're given. So in this case we're given a maximum of pi over 2, 105 and a minimum of pi, 95. And our task is going to be to find the equation, cosine and sine functions of the sinusoidal graphs that fit that data. So our job is going to be to find the equations that fit the basic sine function f of x is equal to a sine b of x minus c plus d, and for f of x is equal to a cosine b times x minus c plus d. So the nice thing about sines and cosines is that a sine function and a cosine function will, for the same set of data, they'll have the same amplitude, the same period, and the same vertical shift. The only thing that changes is the phase shift, the horizontal shift here, the value of c. But A, B, and D will all be the same. So if we look at this picture over here, where the red curve is a sine graph and the green curve is a cosine graph, we can see that all the sine is just shifted the cosine over a tiny little bit. So if I were to take the red sine curve and I were to shift it this way by pi over 2 units, and they would line up directly on top of each other. So that means that I could say something like, if f of x is equal to the cosine of x and g of x is equal to the sine of x, it'd be very easy to get these to line up on top of each other, because that the cosine of x is going to be equal to the sine of x plus pi over 2. So if I do the sine of x plus pi over 2, that would take this red curve and it would shift it to the left pi over 2 units. So those would equal out. And if we examine that on the unit circle, we'd find that that's also true, whereas in something like the cosine of 0 is equal to the sine of 0 plus pi over 2. Right? The cosine of 0 is equal to the sine of 0 plus pi over 2. We know this to be true because the cosine of 0 is 1. The sine of 0 plus pi over 2, that becomes sine of pi over 2, that also equals 1. So this relationship is always going to be true. So if I take the sine and I shift it, it equals the cosine. So what I'm going to do in this case, where I have a maximum and a minimum, is I want to first draw a picture for myself to give myself sort of a visual representation of what the graph is going to look like. So the first thing I'm going to do is say, all right, the point pi over 2, 105. I'm going to sort of create my scale down here. And I'm going to call this here, this can be pi over 2. This can be pi. This can be 3 pi over 2. This can be 2 pi. And so at pi over 2, 105, I'm going to put that right up top here. This will be pi over 2, 105. That's my maximum. And at pi 95, that's going to be my minimum. So really what I have here is, if I kind of connect these, this becomes half of one period. All right, I've gone from a maximum to a minimum. Or if I look over at this area, I've kind of gone from a maximum here to a minimum there. All right, so that's half of one period. So if I go from the maximum to the minimum and then back to the maximum again, that would be a full period, and that's really what I need to have. So since the distance, the horizontal distance between these is x over 2, I need to go x over 2 units again. That will give me 3 pi over 2, or sorry, pi over 2 units between them. So I'm going to go pi over 2 units again. That's going to bring me back to 3 pi over 2, and that would be this point right here approximately, and this is going to be 3 pi over 2, 105. So if I continue my graph up to there, now I've got one full period where I've gone from a maximum down to a minimum, back to a maximum again, and this is going to give me one full period of whichever function I decide to use. So the next thing I'm going to do is I'm going to draw my midline. I know that my midline has to be halfway between the maximum and the minimum, just like it is over here. The x-axis is halfway between the maximum and the minimum. So since my maximum is at 105, my minimum is at 95, that means that my midline, let me get a different color real quick, means my midline is going to be right here in the center. So halfway between 105 and 95 is going to be a value of 100. So that means that I've found D, right? D is my midline. D is going to equal 100. So I'll just put that right over here. D is equal to 100. Well, the other part I have now is I have my full period. I know my period goes from pi over 2 to 3 pi over 2. So if my period is going to equal pi units, that means that I can find the value of B. Remember, B is equal to 2 pi over the period, which in this case is pi. So B in this case is going to equal 2. So I've found D and I've found B. The next piece I need to find is A. Alright, so my amplitude is always going to equal the distance between the maximum and the midline, or the minimum and the midline. And in both cases, I've gone from 100 up to 105, so that's a distance of 5 units. Here I've gone from 100 down to 95, that's also a distance of 5 units. So the value of A I've found is going to be 5. I know my amplitude now. So I have A, B, and D. And because A, B, and D are going to be the same for both functions, I've also found A, B, and D for my cosine function as well. So now the trick is just to find my value of C. Okay? Well, I know that my period is going to be pi. So I can figure out, well, is my cosine graph or my sine graph going to start at the top, or is my cosine or sine graph going to start in the midline? I just got to remember what the rules are. So I know for a sine graph, it has to start on the midline increasing. Okay? So I have a point right here where it's on the midline increasing. And if I go one period back the other way, I should also have a point where it's on the midline increasing. So because this right here is between pi and 3 pi over 2, it's got to be halfway. This is actually going to be at 5 pi over 4, comma 100. And that would be a point right on the midline. Well, same thing. If I go 1/4 of the period here, this is also going to give me pi over 4, comma 100. So that means that my sine graph, if I continue this down, my sine graph actually starts right here on the midline. So I can use this distance right here as my horizontal shift. So for the sine graph, we know that C is equal to pi over 4 to the right. That's just going to be pi over 4. Okay. For the cosine graph, we're a little bit different, right? For the cosine graph, we want to start in the top going down. So we want this distance here to be the horizontal shift for our cosine graph. So that's going to be easy. That's the distance right here of pi over 2. So for the cosine graph, C is going to equal a shift of pi over 2. So now I've found C for my sine graph and C for my cosine graph. I'm ready to create my equations. So for first, we're going to do the sine. We have f of x is equal to our amplitude, which was 5, times the sine of b, which in this case here was 2, times x minus our phase shift. So in this case, it was pi over 4 to the right. So x minus pi over 4, plus our midline, which is plus 100. For the cosine, we could write f of x is equal to, now again, remember that a, b, and d are the same. The only thing that changes is c. So I can just write 5 cosine 2 x minus blank plus 100. All right, and then we go back and figure out that, okay, for the cosine value, the shift was pi over 2 units, so that's just be x minus pi over 2. So if we wanted to know the sine function and the cosine function that have a maximum at pi over 2, 105, and a minimum at pi, comma 95, this here would be the sine function, and this here would be the cosine function. I hope this helps kind of clear up a little bit between sines and cosines and how they fit together. Good luck, and I'll see you in the next video.